Hello, and welcome to the module on chemical stoichiometry. In this module, our focus is to learn what information we can pull from a chemical formula. Our first example here is Al2O3. So when we look at and compare the aluminum to the oxygen, we notice that it's a 2:3 ratio. I get the numbers 2 and 3 from the chemical formula itself. Now, as soon as I write that ratio, I can treat it as such. So I have 2 something of aluminum, aluminum is Al, to 3 something oxygen. What I do to the left, I do to the right. So if I have 2 atoms of aluminum, then I have 3 atoms of oxygen O, monatomic oxygen. I can also do 2 Al2,3O with moles. So I can have 2 moles of aluminum. I will have 3 moles of oxygen. So you see that there is a ratio, a relationship that exists between the aluminum and the oxygen that's dictated by the chemical formula. I also have other ratios that I can write, such as 2 moles of aluminum to 1 mole of the whole compound overall. Again, using the subscript on the aluminum. Likewise, I can say I have 3 moles of monatomic oxygen for every 1 mole of my substance, Al2O3. Now I can use these relationships and I can write them in such a way that I can use them in a in a mathematical relationship to do a problem. So I can write 2 atoms of aluminum per 3 atoms of oxygen, or I can write that upside down and say 3 atoms of oxygen per 2 atoms of aluminum. And I can do that sort of relationship for every one of these that I've listed. So I can also say 2 moles of aluminum per 3 moles of oxygen, and so forth. So let's see now, assuming that you figured out that trend, let's see now how we can use that in a calculation. I need to know how many moles of carbon, C, are in 6 moles of sugar. Sugar. So I have 6 moles of C6H12O6. And now I want to multiply somehow. Now I use my mole-mole ratio. The mole-mole ratio is just what we've done above. Notice that up here we have moles on top, moles on bottom. That's called a mole-mole ratio. So when you hear people say that aloud, that's what they're talking about. So here my mole-mole ratio, let's see, I want to get rid of moles of C6H12O6 and put in there the moles that I'm looking for, which is carbon. I notice that on the carbon is a 6, so every 1 mole of my molecule, I have 6 moles of carbon. So I have, 6 times 6 is 36 moles of carbon. And that's my answer. Likewise, if I had 10 moles of sugar, I'd have 60 moles of carbon, and so forth. All right, let's do another example. Here I want to know how many moles of oxygen is in 0.051 moles of, not in the moles of Fe, but I have my sample. I have this many moles of iron in that sample, so I can use my ratio to find for oxygen. So moles of Fe on the bottom, moles of O on the top. I have 2, I have 3, and I get 0.077 moles of monatomic oxygen. Thank you for working this with me.